Hello everybody, this is Mr. Kinney in the ongoing series of our stoichiometry practice problem sheets. This is the mixed mole problems, and let me zoom out here a little bit so we can see the whole thing. Now, working with these, question number one kind of threw a few people, but let's kind of back up a little bit and coming back to our objective sheet showing our mole conversion chart. Mole being the most valuable player of chemistry. The mole lets us convert between mass to volume. And on your paper here, we call this representative particles. I would recommend representative particles. Okay, that was from a copy I got from a website. I'd rather you put molecule. How about number of molecules? Or atoms? Or ions, if we were doing an ionic one. So we have done all sorts of practicing now. You've practiced going back and forth here. We've had you practice between moles to moles. We've had you practice starting at mass, going to moles, converting over to moles of the other compound, and coming back here. So what this one is we're just going to have you kind of just a little mix of everything. But we haven't practice this one right here. We haven't had you practice going from moles to number of particles or number of particles back to the mole. And it's just like we've done everything else. If we're going to number of particles, we're going to be multiplying by Avogadro's number, 6.02 times 10 to the 23. Or if we're going from number of particles to moles, we're just dividing by this. Now, you will need a calculator for this. You can't get around this. Well, you can get around it, but it's a little bit more difficult. And excuse me, I'm just looking at my calculator to see which way I want to go here. So anyway, let me grab the ones. Okay. So you'll need a calculator, and calculators will tend to have, so when you put in the huge numbers, they will either have a button, it'll say like this one, EE for engineering exponent. That'll let us put the times 10 to the 23. It might say EXP. It might be a 10 to the X up here. So you just need to make sure you know how to use your calculator. So let's get working on these. Keeping in mind, this is still our roadmap. So we're starting with how many grams are there in this many molecules of carbon, and that's supposed to be CO2. Sorry, that was a typo. I'll have to fix that. So how many grams are there? So we're looking for grams of CO2, and we're given this. This is our given. So if we take a look over here, I'm going to get this chart back. So we're given number of molecules, and we want to know how many grams will that be. So it's going to be a two-step conversion. We're going to convert number of molecules into moles by dividing, in this case, by Avogadro's number. That'll give us moles, and then we're going to convert that into grams by multiplying by the molar mass of CO2. So to get this set up, we just put what's given. 9.03 times 10 to the 23 molecules. I'm going to have to write that one out because I don't want you to get confused with moles. So it's a fairly big number. Now, on your calculators, well, okay, let's just get the problem set up, then we'll show you how to use it. So we're just going to do our first conversion, and our first conversion is to change number of molecules into moles, and we're going to divide by Avogadro's number, 6.02 times 10 to the 23. So 6.02 times 10, let me zoom in here a little more, times 10 to the 23 molecules of, oh, you know what, let me back over to here. This should be molecules of CO2, okay? So there are Avogadro's number of molecules of CO2 in 1 mole of CO2. Okay, so all we've done here is just setting up, we just converted from number of molecules to mole. And we can cancel out number of molecules with number of molecules. And in this, well, okay, I'll show you the canceling out here in just a moment because it's a little bit easier than it looks. So now what we've done is we've gone to moles, but we need to go to the next step. We need to go from moles to grams, because that's what this problem was asking, and we do that by multiplying by the molar mass of CO2. And 1 mole of CO2, okay, I'm gonna, oh darn it, I don't have my sheet in front of me. Okay, let me see, sorry about that. See, oxygen is 16 times 2 is 32, and then let's see, carbon is 12. Yeah, I thought it was 44, but I didn't want to mess you up here. So 1 mole of carbon dioxide is 44 grams of carbon dioxide. We'll wait for, okay, so anyway, so we will cancel out the mole of CO2 with the mole of CO2 there. Now, what you can do is, now you're going to be able to use calculators. We used to have to teach this where you couldn't use a calculator. But one nice thing is you could look at this, since we've got the same exponents here, we could just cancel off times 10 to the 23 times 10 to the 23, and now it just becomes 9.03 times 44 divided by 6.02. Okay, because we can cancel always on stoichiometric problems. If you can cancel stuff out, do so. You reduce them as much as you can. Now, I'm going to go through with the calculator. I'm going to not reduce out the molecules here. I'm going to just enter it in to show you how you would do it. So to set this problem up, so we'll start off there. Oh, turn this on. 9.03 exponent. Now, I hit the exponent button, 23. So we've got that in there. Now the next step is I need to divide it by our Avogadro's number. So now I'm just going to hit the divide button, because that's what we can do on these. So now I'm going to divide it by 6.02, and then I'm hitting hitting the EE button. It might be the EXP, exponent button on yours. 23. Okay, so now when I hit the times button, because what's nice about the scientific calculators, I've entered the first number, I've hit divide by this number, I'm going to multiply finally by 44 times 44, and see that this is 9.03 times 10 to the 23 divided by 6.02 times 10 to the 23, but I'm going to multiply it by 44, because that's the molar mass we have there, equals 66, 66 grams of CO2. So that's how you'd work that out. So when you're using your calculators, you just need to use either the EE or the EXP button, and you may not use your cell phones when we do the unit exam on this, so you need to either get yourself a calculator. You can check out these from me. You just need to know how to do it, because you don't want to have to figure out how to do this during the test, because I won't be able to do that with you. So just zipping through the rest of these now, because we're already at 8 minutes on this. So this next one is going to be, what volume would this many molecules occupy at STP? Now again, a reminder for you, STP just means standard temperature and pressure. It just is, it's telling us that it's 0 degrees Celsius and 1 atmosphere, which is kind of what scientists say that's the standard for doing these reactions. So you don't have to worry about this right now in the stoichiometry unit. But what you do need to do, we're going from volume to molecules, and it's of this same one. It looks like it's going to be CO2. So you're going to start over here with volume, and then to change that into moles, you're going to divide by 22.4 liters. Then you're going to, and again, then you're going to multiply by, in this case, you're going to multiply by Avogadro's number to find out how many molecules there are. So, oh, wait a minute, I apologize, I said that backwards. Wait, our given, see, I didn't do the given thing, I need to do that. What volume? Okay, so we're looking for liters of CO2. Okay, put that down. See, I didn't do it, and I got myself back to, and see, you can do that in a problem. If you don't do this find, give, and solve, you could end up calculating the wrong thing. So we're looking for liters of CO2, and the given is we have that many molecules. So, excuse me, it's just the opposite of what I said. We're starting with the number of molecules, dividing by Avogadro's number, excuse me, just like we did before. Then we're going to multiply to convert it over to volume of gas. Sorry for that. This one right here, number 3, a sample of ammonia occupies this many liters at STP. How many molecules is this? So we're looking for molecules. Molecules, I'm going to zoom out on these because I'm not actually doing the calculations. We're looking for molecules of NH3. Okay. And what is given? We have 56 liters of, this is the given. So we're going from 56 liters right here. Going to convert that to moles. And then we're looking for how many molecules. Then we will actually multiply by Avogadro's number to get us molecules. Number 4, what is the mass of a sample of ammonia gas? Okay, so mass, that's going to be grams of NH3. So we're looking for grams, which occupies this many liters. So this is our given. So in this problem, we're going from liters, going to convert it to moles by dividing by 22.4. And we're going to multiply it by the molar mass of, what was this, ammonia here? Okay, so you have to look up the molar mass of ammonia. And then, so two-step conversion. Number 5, how many molecules are there of NO2? Okay, so we're looking for molecules, NO2. And that's given us, we've got 5 moles of NO2. Well, that's going to be pretty easy because we're just going from moles to molecules. We just got a one-step conversion. We're going to put this as our given, and we're going to multiply it by Avogadro's number, that many number, and that'll give us your answer. Number 6, over here, let's see, we've got this many grams of oxygen is sealed in a container at standard temperature and pressure. What volume is the container? So we're looking for volume. Okay, so volume, excuse me, that would be liters of O2. Liters of O2, that's volume. And we're given, this is our given, this is what we're starting with. So we've got, we're starting here at grams, and we're going to liters. You're starting at grams, converting it to moles, and then once you've got the moles, you're going to convert it into liters by multiplying, since we're going that way. Remember, whatever you're converting to, in this case, we're converting to volume. The volume is 22.4 liters in 1 mole. Lastly, number 7 here. You have 33.6 liters in a sealed container of gas. That's STP. That's our given. That's what we're converting. And let's see, how many molecules? So we're looking for molecules of O2. All right, so in this problem, so we're going from liters to molecules, just like we did in the previous one. We know that we've got 33.6 liters. Well, then, since we're going to moles, we have to divide by 22.4. That'll give us moles of O2. And then, since we're looking for molecules, then we follow this path. We're going to multiply by Avogadro's number to end up with the number of molecules we need. So 2-step conversions there. See you later, everybody. Goodbye.